Okay, the intro to trig notes are covering something called angles of rotation. Not all trig exists inside of right triangles. A lot of trig is generated by these angles of rotation, but what we're going to start doing is we're going to start by taking our angles of rotation and making right triangles out of them so that we're teaching it to you guys at the level you have seen it before as right triangles. And then very, very quickly in the next few days, we're going to stop making right triangles out of them and just do angles of rotation. But in order to do either level of that, you need to know how to draw an angle in what we call standard position and make an angle of rotation out of it. And so angles of rotation are a lot like the games that you play that have spinners on them, like Twister and other games like that. What happens is that you have what we call the initial ray of your angle. And so it's a lot like a geometry angle. It's got an initial ray, and it's going to have a terminal ray, and that terminal ray is the spinning arm that gets to go in either direction, however many times around it wants to go. It just keeps going and going. And so the terminal ray is the side of the angle that is free to stop somewhere else. The initial ray always has to be on the positive x-axis, and if you look up here in the definition, it says that the vertex also has to be on the origin. So what you'll have is you'll have the vertex on the origin, you'll have your initial side always pointing to the right, always on the positive x-axis, and then the terminal side is free to rotate anywhere it wants to rotate, and then wherever it comes to stop or comes to rest is where our angle is located. If the terminal side of your angle is rotating counterclockwise, then you have a positive angle. And people get that mixed up because they assume clockwise is the direction that all spinning things move because of clocks, of course. But if it helps you, think of it this way. Here's my vertex, here's my initial side or my initial ray. If I'm rotating counterclockwise, that makes it a positive angle because of the fact that it's rotating up first. Even if that angle spun all the way around down here into quadrant 3, which has negative numbers all over the place, it still spun up first. And so that's what would make it a positive angle. If you have an angle that rotates clockwise, so once again, standard position would put the vertex there on the origin, the initial side on the positive x-axis, and if the terminal side is rotating clockwise, even if it rotates all the way around up into the positive numbers, it started by rotating down, and so that makes it a negative angle. No matter where it ends up, it started by rotating down. Now what we're going to need to make those right triangles out of our pictures is, once we have drawn our angles in standard position and we have figured out where they have stopped or where they have terminated, we're going to need to locate the reference angle. The reference angle is the angle for which all of the trig is going to be based. So the reference angle is, I think, one of the most important parts of these angles of rotation, if not the most important part. So if I have an angle in standard position and it spins around, I don't know which way it spun, I don't know how many times it spun around, but if it finally came to rest somewhere here in quadrant 1, then the definition of the reference angle says it's the angle made by the terminating side and the x-axis, and it's always acute. So what it's asking you is it's asking you for the smallest angle back to the x-axis. And so in that case, this angle right there, that's the smallest angle to the x-axis. You only have two options. Option 1 would have been this angle that actually was our reference angle, or it would have been this angle, and that angle's not acute. So find your terminating side and figure out which angle to the x-axis is the acute one, or the smaller angle. So if you have an angle in standard position and it rotates around, we don't know which way, we don't know how far, but it comes to rest over here in quadrant 2. Then this time, the reference angle would be this angle right there, because this is the smaller angle to the x-axis. This angle over here is too big. It's not acute, because remember, acute means less than 90 degrees. So this is the reference angle, just like this was. So what I want you to do really quick is I want you to sketch an angle in standard position that terminates in quadrant 3 and figure out which way the reference angle would go, and then draw an angle in standard position that terminates in quadrant 4 and figure out which way its reference angle would go. So pause for just a second and do that. Okay, hopefully you paused, and when you turned the video back on, you had drawn an angle that terminated somewhere over here. Okay, and that means that this angle right here is the smaller angle to the x-axis, so this would be your reference angle. And I'm just calling it R for right now. You can call it lots of different things, and then an angle in standard position that terminates over here in quadrant 4. You only have two options. Option 1 would be to go this way back to the x-axis, which is not acute, it's way too big. Option 2 is this one right here, so this is your reference angle. So almost the whole first homework assignment is this. It's drawing angles in standard position, it's figuring out where they terminate, and it's labeling the reference angle and finding the size of the reference angle. There are a few that you can't find reference angles for because they're going to terminate on an axis, and those are called the quadrantal angles because they terminate on a quadrant. And so if I have an angle in standard position, let's say I just rotated 90 degrees up, so positive 90 degrees, that means I terminate pointing straight up. The reason I can't find a reference angle is two reasons. The first is that no matter which way I go, this way or this way, I have the same size angle to the x-axis. And a reference angle is supposed to be the smaller angle to the x-axis. The second reason is that the reference angle has to be acute because it's an angle that we're going to fit inside of a triangle, and 90 degrees is not acute. So that won't work. If I have an angle in standard position that swung around and terminated over here, I'm already on the x-axis. So if I went 180 degrees, I'm terminating on the x-axis. There is no angle between where I terminated and the x-axis. If I have an angle, even if I rotated down, if I rotated down 90 degrees, that means I'm pointing straight down, and I have the same situation that I did in the first diagram. I have two angles that are the same size to the right and to the left to get back to the x-axis, but they're also not acute. And then of course the final option would be if you have an angle that actually comes back around and terminates right here on top of its initial side. Once again, you're right on top of the x-axis. So 0 degrees if you didn't rotate at all, or if you swung all the way around to 360 or anything like that, you are already on the x-axis. You can't make a right triangle out of it. There's no angle between where you terminated and the x-axis. The Greek letter theta is what we use to represent a lot of angles. I mean, we will use x's and angle A and angle B, but we use theta a lot of the time. So you do need to become familiar with that symbol. And then the next thing that your homework is going to ask you to do is it's going to ask you to find what we call coterminal angles. So if you think about what the different pieces of that word mean, co means to do something together. So cooperate means to work together, cohabitate means to live together. And so we're talking about angles that are terminating together. And so that means they have to end up on top of each other. So a really easy example would be if I rotated up positive 90 degrees, that means I am terminating straight up. But there are lots of other angles that will end up in that same place. I could have started here at 0 and rotated negative 270 degrees. I still end up pointing straight up. Or, so that my diagram doesn't get any more cluttered than it already is, I could have started here at 0. And remember, the terminating side is like a spinning arm. It can keep going around and around, like on a game board. So I could have gone all the way around 360 and then gone another 90. And so that means that I went all the way around 360 plus another 90. And so I have now rotated 450 degrees, but I still end up pointing straight up. So I want you guys to take a second and come up with one other angle. 2 would be even better, but come up with at least one other angle that also terminates pointing straight up in that last diagram. Okay, so hopefully you paused it and you found at least one. I'm going to give you 2. I'm going to give you one more positive angle and one more negative angle. So if you started here at 0 and you want to terminate here at 90, so I'm already at 90, right? And we've already talked about, well, I could go all the way around one more time and that had put me at 450 total. But since this spinning arm can go around again and again and again, I could go around even another 360. And so that would put me at 810 degrees because all I've done is I've added 360 again. Or, and I'm going to erase the actual arc, so I'm going to leave that 810, but I want to erase this so I can draw a negative angle. Okay, so once again, I want to terminate here at 90, right? And so we've already come up with this negative 270 over here. So how about if I start at the 90, I go backwards 360, that's what gave me the negative 270, and then I go backwards another 360, so now I'm at negative 630 degrees. And so hopefully what you've noticed is that literally all I've done is I started out at that 90-degree angle that I wanted to terminate with, and I have literally just started over and over repeatedly adding or subtracting 360 degrees. And the way that we write that is we attach an n to it, because n is talking about the number of times that you can just keep going around. N could be 1 time that you went around. N could be 2 times that you went around. Okay, and the one final thing on today's notes is that we're not going to work in degrees most of the time. We're going to work in a unit called radians. And you guys have seen radians. I think most of you, unfortunately, have just been made to memorize radians, though. So what we need to do is we need to be able to draw angles in radians. We need to be able to find reference angles in radians. We need to be able to do coterminal angles in radians. But we start out, once again, we start out doing stuff in degrees, and then we simply convert to radians until you guys get good with radians. Okay, so I want to show you guys that when I do that, you guys remember your dimensional analysis from chemistry. So let's say I took 6 feet. and I wanted to convert it to inches. Okay, so in dimensional analysis or quantitative analysis, what you're taught is that you take your conversion factor, which 1 foot is 12 inches, and you orient it so that the unit you're trying to convert out of goes on bottom, and the unit you're trying to convert into goes on top, because units cancel just like numbers do. So if there's feet up here on top, they'll cancel with the feet down here on bottom, and then the arrangement of the numbers tells you whether you're going to be multiplying or dividing to get your answer. And so the 6 and the 12 are both on top, and you would multiply and get 72 inches. You could do that in reverse. So if you want to go in the other direction, you simply take your conversion factor and flip it. It's still 12 inches is 1 foot, but now the 12 inches has to go on bottom, and the 1 foot has to go on top. And so the inches will cancel, and this time the 72 is on top, but the 12 is on bottom, and that tells you to divide, and you would get your 6 feet back. So the conversion factor for radians into degrees and vice versa is that pi radians is equal to 180 degrees. And the reason that we use radians predominantly in advanced math courses is because radians is an invisible unit. You don't have to write the word radians. You don't even have to abbreviate it. You don't have to write anything. Okay? So what we want to do is we want to practice taking that conversion factor and orienting it the different directions. So if I wanted to convert 210 degrees into radians, I would take my conversion factor, pi and 180 degrees, and I would orient it so that the 180 degrees was on bottom, because degrees are my units that I'm canceling out of, and I would put my pi radians on top. And you notice I didn't write anything but pi. I didn't write the word radians or anything. And then what would happen is that the units, the degrees, would cancel, and I would have 210 times pi on top, and I would have 180 on bottom, and then I would simply just reduce the fraction. And the first thing I would do to reduce it would be to cancel 10 out of it to get rid of the 0 at each end. So I would have 21 times pi over 18. And then, of course, a 3 would reduce out of each one as well, and so I would end up with 7 pi over 6. So 7 pi over 6 is the same angle as 210 degrees. Just like 6 feet and 72 inches are the same length, just different ways of measuring them. So if we want to go the other direction, if I wanted to take 3 pi fourths and I wanted to convert it into degrees, I would simply take my conversion factor and flip it. So this time pi and the invisible word radians that's behind it, that's what I want to cancel out of, and I want to go into degrees, so degrees goes on top. And this time, the pi's would cancel, and I would have 3 times 180 degrees divided by 4. Now, the most common thing that people struggle with actually with this particular type of problem is they want to do all their multiplying first on top before they divide. That's not wrong, it's just making it harder. Usually what we recommend you do is you take the 180 and divide it by 4 first, and what you'll get is 45 degrees, and then triple it. And so you'll get 135 degrees. You can multiply first. I mean, if you want to do 3 times 180 and you want to get 540 degrees, and then you want to divide by 4, you'll still get the same answer. It's just a matter of what order you want to multiply and divide in. Okay? So that's it for the intro to trig notes. Your first homework, like I said, it's going to cover 2 days of notes. There's only 2 days of notes in this whole unit. The homework you're going to be working on Friday in class. You're not going to finish until after Monday's notes, and then we're going to check it on Tuesday. So you've got plenty of time to practice this, and I will be back with you guys on Monday. Have a good weekend.